In this video, we will talk about the velocity in one dimension. Velocity is a vector quantity. Therefore, it requires the specification of both direction and magnitude. In this video, we deal with one-dimensional motion. Thus, we can indicate vector direction by using positive and negative signs. In one dimension and along the x-axis, average velocity is given by the change in abscissa, delta x, over the corresponding duration, delta t. The subscripts I and f correspond respectively to the initial and final positions. Note that in this case, the magnitude v bar is the absolute value of the average velocity. Also note that the magnitude is a scalar quantity. Therefore, it has a numerical value and no direction. In the International System of Units, x is expressed in meters, t in seconds, and the value of the average velocity in meters per second. We often need to know the instantaneous velocity, which is the velocity of a particle at some specific instant rather than the average velocity over a time interval. But since we cannot freeze time and talk about motion at a specific instant, we compute the instantaneous velocity as the average velocity around that instant. This can be done by taking a very small time interval with respect to the total duration of the motion. Therefore, in one dimension and along the x-axis, the instantaneous velocity is given by this formula, which means that it is equal to the limiting value of the average velocity as the duration approaches zero. Thus, it is equal to the ratio delta x over delta t as delta t approaches zero. Note that the magnitude v of the instantaneous velocity vx is equal to its absolute value. If the abscissas of the particle are known at different instants, this formula can be replaced with an acceptable precision by this other formula, which means the instantaneous velocity at a certain instant tn by computing the average velocity between the previous instant tn minus 1 and the next instant tn plus 1. Also note that in this case, the magnitude Vn of the instantaneous velocity Vxn is equal to its absolute value. In the International System of Units, Vx and V are expressed in meters per second. Example, a puck has a rectilinear motion on an inclined air table. The abscissas of the dot marks corresponding to the positions of its center of mass for equal time intervals tau equals 80 milliseconds are represented in the table below at a scale 1 to 4. 1. Calculate its average velocity between P0 and P5. 2. Calculate its instantaneous speed V3 at P3. Note that instantaneous is written between parentheses because whenever we say speed without specifying, we are talking about instantaneous speed. For question 1, we write the general formula of the average velocity and we apply it between P0 and P5 of respective abscissas x0 and x5, knowing that the duration delta t between these 2 points is equal to 5 time intervals tau. We replace x0 and x5 by their values. We convert centimeters into meters. We multiply by the reciprocal of the scale to get the real value. We replace tau by its value, and we convert milliseconds into seconds. We get minus 1.5 meters per second. For question 2, we know that the instantaneous speed is the magnitude of the instantaneous velocity. Thus, it is equal to its absolute value. We write its general formula and we apply it at P3, which means between P2 and P4 of respective abscissas x2 and x4, knowing that the duration delta t between these 2 points is equal to 2 time intervals tau. We replace x2 and x4 by their values. We convert centimeters into meters. We multiply by the reciprocal of the scale to get the real value. We replace tau by its value, and we convert milliseconds into seconds. We get 1.6 meters per second. And this is all for this video. Thank you for watching.